Hello, everybody. Welcome to Very Basics Spatial Statistics. My name is Patricia. I know you've been working with Blake in the previous workshop series. I also work at the center. And just full disclosure about me, I did not like statistics in college. I thought it was white balls and black balls and probabilities. And so you might not have somebody who is extremely passionate in the foundation, but Spatial Statistics changed me like 180 degrees. I absolutely love the topic. It's so applicable. It's so easy, at least for me to understand. So that's my goal with you. I hope you feel as passionate as I am about Spatial Statistics. Can I get a little bit of information about you, if you're, your major or discipline interest, and how comfortable do you feel with the concept of p-values and z-scores? And I'll start with you.
I'm Harshita, and I'm a PhD student in civil engineering.
Okay.
Presently, I don't have any work in GIS, but I'm utilized to use in my further research.
Okay. And p-values, z-scores, you're probably very comfortable with those.
I'm very new to GIS, and I'm in this training.
All right. And but basic statistics?
No,
not much. Okay, that's fine. Yeah, that's fine. I'm also originally from Spain, so I tend to say statistics instead of statistics, or Spain instead of Spain. So just bear with me with I've been in this country 15 years. It's still, the accent is very hard to let go completely. So I just noticed I say statistics. Dr. Colleen.
I've been working with stats stuff on my business, so I'm kind of comfortable with it, having been an administrator for 10 years or more. I haven't done it like day to day, so I'm just kind of getting back into it.
Okay. So you might help me with some of those concepts.
I'll point to the plate.
Okay, we'll help each other. All right.
Tom Coco, doing my PhD in entomology. What else? I mean, z-scores and
Yeah. I'm sure you're
z-scores. I'm going to get fresh on.
right.
Yeah. Trying to learn something about it.
Okay. Any needs for spatial statistics for your PhD?
No, I'm just at basics.
Okay. Do you work with Dr. Colin?
No.
Okay. He has quite the collection.
Yeah.
And a very interesting class with the movies and yeah. Do you mind telling him? I don't know if he knows about it.
The class.
Your class?
My last class.
Yeah.
Ever will be next Monday night. Yeah.
Next. Oh, really?
Watching the movies, and we're watching Big Ass Spider.
Okay.
So it's not real science, but
Right.
looks at how filmmakers portray scientists.
Right.
So it's fun.
Yeah. Thank you.
I'm HNC. I'm also a PhD in entomology.
Entomology.
Yeah, I know the very basics.
Okay. All right. Thank you.
Terry Green, I got my MBA with Clemson a few years ago,
Uh-huh.
and I had a little bit of p-values, but not
Right.
recently.
Okay.
But my interest in the whole GIS, do some work with a land survey company, but also business and agriculture.
Business and agriculture. Okay.
Jacob Murray, I'm an undergrad here in the forestry department. I'm pretty familiar with like statistics and p-values and stuff like
Hey.
that.
I studied forestry, so I know you're probably familiar with those people. I didn't like them in forestry as much as I like them in GIS, but yeah. So, but you are the only undergrad.
Yes.
Okay. All right. All right. So we're gonna get started with the content itself. If you can go to your D drive. We have, these computers have a 2 terabyte hard drive space where you can put whatever you need or want. So that's pretty convenient. I'm going to do it myself. And Kaylee is online. So I hope, Kaylee, you can hear us and follow us through. So if you navigate to the D drive, you should see a folder called Basic Spatial Statistics, February 2018. So full disclosure, I don't know if any of you are familiar with the Spanish history and a dictator that we had years ago called Franco. Well, some students call me Franco because of my very strong feelings about data management with GIS data. So you will see long, meaningful names, very organized data. Part of the reason for that is that I had PhD students crying 2 weeks before their thesis defense because they couldn't find their GIS data. And I promised myself I will never let that happen again, if I could help it. So we are gonna do a little bit of projections, data management. As part of statistics, I think the workshop series should build and refresh concepts that you've done before. And so forgive me if we go a little bit slow and we reinforce some concepts that you've been through in the previous workshop. But those are very important because once we start with analysis, if your data is not in the right projection, or if it's not, you don't have all the values that you need to, then you might get a very pretty map, but your results could be all skewed or inaccurate. And so I want to avoid that as much as we can. So do all of you have this folder, Basic Spatial Statistics, February 18? So if you go there, you will see a PDF that has the slides. That is where I'm going to go through. So we are in workshop number 6. You are one workshop over. Once you finish this workshop, you are like more than halfway through. I have to tell you, this is where it gets really fun. I hope you have fun with spatial analysis, but any true real GIS project or research project for that matter, 95% of your time, 90% of your time is getting the data to the point where you can do analysis. So to me, the most important workshop in the whole series is the second one, which is the most boring one. But I always compare GIS to, a sport. I don't know if any of you have done sports, but if you play volleyball or soccer or basketball, you're just passing for the first few weeks and it's extremely boring and repetitive. And then it gets to the fun part when you can play games. GIS is exactly the same. It's kind of, a lot to take, spatial queries and stuff like that. But once you get to the point where you can do analysis is when it becomes fun. And I know I'm kind of talking like a little bit too passionate about it, but trust me, it's fun. So this is a project that I did when I was back in California. We had a marine station and they had sharks. They were putting like a GPS unit and then they were tracking the sharks and their locations. And one pattern that they came that was very interesting was how the location where they tend to spend most of their time depends on whether they are adults and juveniles and males and females. And so they wanted to understand why were those patterns. And that's what we actually use spatial statistics to look into that data. So if you look in the top corner there, we have basically, this is the data for just one shark for a period for what they called oceanic seasons. And so imagine all those points, you can color them. And so each year is a different color. And then each map is a different oceanic season, right? And so you can start seeing certain patterns from 2004 to 2018. But what if the data is like this? This is when you put all of the shark point data together, that's kind of what it looks. And there's things that you can do to start helping understanding, are there any patterns, any concentrations? So for entomology, for forestry, we have a lot of point data, right? And we can color code it, but that's not an intuitive way. And that's what we're going to be seeing today, to present your data, to communicate and to analyze the results. So there are things that we can do as looking at like density, concentration, hotspot analysis that we're going to be covering. But even more interesting, we can look at non-ambiguous spatial statistics techniques, such as looking at the mean center and the standard deviation ellipse that looks at the core, the 68% of your data normalized around the mean average, and looking at distribution. So if you look at the maps on the bottom, is every oceanic season we calculate that standard deviation ellipse, and then you can see a trend or a pattern. So you can see that in the second oceanic season, the distribution really moved farther up north. And so then we can start understanding why did it go from south to north and then back to south. Well, that was an El Nino year, and so the sharks move up north. But unless we can understand the data and understand if there are any patterns, we cannot start looking even at predictors. So we're not going to be covering regression, spatial regression, in this workshop, but everything that we're doing is going to lead you to the spatial regression. What we're going to be doing is looking at patterns, clusters, because when you have a cluster, that means there are some factors that are pushing those concentrations in those clusters. And entomologists, you know that very well, right? Healthcare is the same thing. So this is kind of the outline. Any sort of statistical method, always to start with exploring your data. You need to understand if it fills the assumptions, is this normally distributed. So I'm going to show you some really neat tools that we have in ArcGIS that we can use for that. And then we're going to dive into what is defined as like the two types of spatial statistics. Descriptive statistics that really looks at things like just describing the data itself. We are not making any inference or guess or conclusion. We are just trying to describe the data. So things like histograms, trend analysis, and those that I mentioned before, like the standard deviation or ellipse. And then in the second part of the workshop, we're going to move towards inferential spatial statistics that starts with a null hypothesis. In spatial statistics, your null hypothesis is that you have a random distribution. Random distribution of whatever spatial phenomena you can think of, flu cases, mass shootings, whatever you can think of, you can have. If that is random, that means you don't have clustering. That means we cannot move towards regression. And so there are two types that we will talk a little bit later, like global and local. So let me give you an example here that I thought was fascinating. So what do you think is the relationship between the 2012 presidential elections and the Cretaceous, I don't know if I say it correct, Cretaceous coastline of North America? Anybody, any guess? I look at the articles like, this is fascinating. You probably know, but
No.
Go ahead.
It's like Democrats live on the coast.
Right. But I mean, the line is not really on the coast as
Right,
of
that's
now.
where the coast was.
Yeah, exactly. So I thought it was fascinating because it's a very distinct pattern. And so maybe Blake can explain it a little bit better than me. But that's, 100 million years ago, that was the line of the coast, which allowed for a lot of plankton and other materials that were perfect then for cotton. And then when the slave trade happened, a lot of them were brought right there to work on the cotton. And then after World War II, there's still a lot of that population, like the descendant of that population, exactly in those counties that you see on the left corner. But to me, this example is, and spatial historians do this a lot. It's like, look at two very different variables, but they are connected by space. And so when we look at specific disciplines, like entomology, civil engineering, you might look at like your very, very same variables, but spatial statistics allow you to bring very different things together because they share some sort of a spatial relationship, overlap, connection, adjacency, and that's where you're starting to see very interesting things. Any questions or thoughts? Okay, so what are spatial statistics? So if you can think about common statistics, the mathematics are exactly the same as spatial statistics, but in spatial statistics, you incorporate some sort of geography or space into your mathematics. And that can be adjacency, neighborhood, overlap, can be overlap over time, like we had in the previous case. And so you are trying to describe those spatial or geographic distributions, looking at patterns. So for example, if you look at, so I created that map. I don't know if you know about this Science as Art contest that Clemson has. I was like, well, GIS data is beautiful and it can be art. I really encourage you to participate. I didn't take a lot of time. I just pulled a lot of data that I thought was fascinating. It was beautiful on its own. And so you just submit any image of your research and your project. And so in this case, what I submitted was, I would call it mesh, water mesh or meshes of mesh or something like that. So I was looking at shipping lanes by concentration or density of trips. So those are the light blue lines. And then the effect that it has is that you have higher concentration, goes from light blue to yellow to red. Red is like high density, like lots of trips happening in those shipping lanes. And then the dark blue lines are actually flights. And so you can see there on the right hand side is Florida, and then you start moving towards Louisiana and others. So I want you to just look at that map and give me your first thought. Don't overthink it. Don't try to analyze it. Where does your eyes go, and what is it that you're trying to understand when you look at a map like that? Anything. Where the clusters are. Do you tend to look more at the, at the dark blue, the light blue, do you see that red line, Mississippi River? Like what are your thoughts when you see that map?
Because they're like mesh, I like to look at like more of like a solid kind of colors.
Right.
But definitely like lighter compared to darker because I feel like it's like the background of the screen.
Right. Yeah. Me personally, I was also looking at, well, like from here to here, that's very dense. And like, what is this here too? Like once I start, first I just look at the pattern and say, very busy, and I have high concentration here, high concentration there. That's where I start looking, like look at that hub and those hubs, But then I start looking at more like, what is in the middle of the ocean that is really, has a lot of boats going through there, So, that was just, I stared at this for a while, but what I'm trying to get to is that your brain, whenever you see a map, you start looking for patterns right away. You start looking for connections, relationships, and you're trying to get a global picture of what's happening. And so your brain is really a little mini statistic kind of spatial statistics machine. And what spatial statistics do, they're trying to stand what you try to do when you see a map. And so what kind of questions can we answer when we use spatial statistics? So these are some of my favorite, and the reason why is because after I discovered spatial statistics, I'm very careful of not showing point data with just different colors or different sizes. So this example that we have here on the left, those are graffiti's paintings on the streets by different gangs. And so each color is a different gang that you have. So imagine you are trying to enforce like safety. I think this example is in downtown LA, right? What if I go to the chief of police and I show that data and I just have just dots of different colors and say, oh, this gang is over here, this one is over there. We were able to get the graffitis. That's not as powerful or easy to understand as if you have something like this standard deviational ellipses. Those, we will go over them and we will run a couple of those, but basically they are looking at the core of your data, like one standard deviation or two standard deviations. So 98% of your if it's one, it will be 68% of your points, and it just gets rid of one or two outliers. But it's saying the core of the area where that gang is operating is here. And so the interesting part becomes that when I do that for all the different gangs, I can see the areas where they really overlap. It's like, look, if you need to concentrate, because we always have very limited resources, this is an area where you have three different gangs that are going to be overlapping, same thing happening here. And so it's a very different message than just plotting all the points and saying, there you go, you figured out what you need to do with it. And then another common one that we use is just, you hear it all the time. What are the hot spots? If I'm looking at high concentrations of high values, when we look at entomology, what defines an outbreak or a flu epidemic? We need to look at things like hotspots. Have you heard of hotspots before? Used many times, right? To me, when it comes really interesting is when we move from looking at those hotspots or clusters to trying to understand why are those hotspots there. So this is an example, and a lot of the examples that I have here are from Esri, the company that makes ArcGIS. They are the ones that their way of explaining statistics really got me enthusiastic about it, and I love their examples, and that's why I'm sharing a lot of their examples with you. So in this example that they have here, they are looking at people in average age where people die per county in the United States. And if you see, particularly in South Dakota, in that red area, people are dying as young as like 55 years old. Whereas the rest of the counties, the darker blue, it might be like 80s. And so when you are finding those clusters, there are some spatial factors and other factors that are kind of creating that cluster. Those clusters don't happen in nature or in society by random chance. There has to be something behind it that is creating those. So and again, this is not right or wrong, but why do you think we have those numbers there? In South Dakota, why are people dying so young there? Indian reservations. And what does that mean? So we have ethnicity. What else?
Poverty rates.
Huh?
High poverty rates.
Poverty. Disease.
And not enough treatment facilities, hospitals, or
Access to facility, lack of insurance. It can be many things, but that's when it comes really interesting in terms of when you go to CDC or somewhere else and say, look, we have a problem here. You can't just not show them up with all the data. You need to make sure that your results are solid and that they are clear. So instead of mapping all the numbers of 58 here, 56 here, or something like that, or even classifying them, you actually use hotspots. That says there's a statistically significant cluster of values where people are dying significantly younger than anywhere else. We have a problem, let's study. And so we will talk about how do we get ambiguity out of maps, and then we talk in spatial statistics terms. So these are, again, some of the things that we can do. Sometimes instead of patterns, we really want to look at outliers or anomalies. And you need to decide, is that a outlier or anomaly? Is that part of the story and a very important part of the story? Or should I remove it to run my analysis? So one example that they use a lot, for example, you go through a neighborhood and there's this street that has all these house values, but there's a house that is significantly cheaper or more expensive. So that's an outlier. Should I include it in my analysis or should I remove it so I can get a better sense of the neighborhood? And the question is explaining part of the story or not? I like to talk in very simple terms, so forgive me about that. But so these maps here are exactly the same data, diabetes in the US. So these are 4 different ways of presenting the same data, and I want to go over with you a little bit. Any thoughts, comments, reactions to this very 4 different ways of displaying the same data? How can it be the same data when they look so different?
The first one that says diabetes development, it's like just at the highest values.
Right.
Let's look here.
Right. And so I think there's a book called How to Lie with Maps, because what you include, the information that you include, the information that you leave out is very different, right? Here, I'm like, I want to focus there. I don't care about anywhere else. and I'm using red, and red is used for danger, pay attention. So this is the very specific purpose for that map. How about this one here? The one on the top right. And I don't want you to think as a GIS specialist, more as a general audience, like public that will look at that map and say,
It's too mellow.
right? It's like blue, big deal, nothing to worry about here, Most of the states is gray, no problem. And then we have some blue and some purple. It's a very different message from the one on the left, isn't it? Right? So the information that you include, the information that you leave, the colors that you use, all of those will make your map give very different purpose and different ways of presenting the same data. How about this one here? This one violates all the laws of cartography, by the way. Quantitative data with the rainbow colors, there's monochromatic color map. But apart from that,
Way too confusing.
it's way too confusing. Why would you have these values here? Yes, it's just, but it's happy. And there's some problematic areas here. So, but it's a very different message still. A lot of data, trying to be very comprehensive, but it doesn't work. How about the one on the bottom left corner?
I think it's too continuous. I think like if you use that map, you would have to look at the whole eastern half of the United States
Right,
instead of like specifying on the southeast.
right, exactly. Yeah, that's a very good point. So the way, and we're going to go over classifying our data, just bear with me, a quick exercise. What we're going to do exactly this. We're going to map the same data with different classification methods, and then you're going to see how your map changes so much. Okay. So let's compare these two. This is another way that you can change the message of your map. Both of them are the same map. What is the difference between the one at the top and the one at the bottom? These are national car rental locations in the United States.
I can see where they are.
Okay. Yeah, the top one is like, oh, there's locations here and there. The bottom one is like, we're everywhere. Wherever you go, you got your office. It's a very different message. Same map. All it did is change the size of the symbol to just convey a very different message. So spatial statistics take away that ambiguity. You're not looking at colors and size of symbols and classification methods. You're looking at p-values and z-score. So nobody can refute your findings. But here, whenever you do a map and you choose the symbol and the colors and the classification, you're making sort of an arbitrary decision. So I hope you remember this for the future, wherever you have to do a map, but this is kind of important. Same thing here. These are McDonald's locations. Same map. Any thoughts between the one on the left and the one on the right for McDonald's?
The right just seems evenly distributed everywhere.
Okay.
They're blanket.
What do you think the author, when he made this map, was trying to say? I mean, I know about it, so I'm like very biased, but he was from a health magazine saying, fire! They're taking over, like the color that I use, that, kind of fire flames, and they're just everywhere. What are we doing with fast food? And this one is Happy Meals, the numbers are concentrated. This one is 173, this one is 211 locations. But it's, we're everywhere, we're happy. So it's a very different message with the same data. And so spatial statistics allows us to change that. Let's do it together. So we are going to be looking at mapping some, and actually this example is like children under 5 in the US, but we can choose any category of your liking. And so we are going to classify the same data with 3 different methods, and then you're going to see how important it is. Okay, so to do that, let's open ArcMap. Have you done this before, like the classification methods? When you do symbology in our map, you have natural breaks versus equal interval, standard deviation, quantiles. So we're going to do that. I know it's kind of basic, but it's very important for GIS. And our map takes its sweet time. Anybody got our map? I don't. You do? Ah. You do? You do. I'm a very impatient person that works every day with a very patient program. We're not very compatible most of the time. Okay, and it open up. This window that shows up, you can just close it if you have it. And then I'm bringing our map. So all of you have ArcMap open? Everybody has ArcMap open? Okay, so we are going to connect to this folder on the D drive. So if you open our catalog is that little, the one with the yellow storing kind of place. And so we're going to connect to the folder for this workshop. If you remember how to connect to the folder, you go to this button over here with the plus hand side, connect to folder. And now we're going to navigate to computer, the D drive, data 2, D drive. And then we're going to connect to this basic spatial statistics, February 2018. So just navigate to that folder and then click OK. And then it will show up as one of your folder connections. D Basic Spatial Statistics, February 2018. Everybody here? Yeah? Okay, so we are going to expand. Clicking on that plus hand side on the left, we're going to expand that folder view. And I know it just takes a while. I don't know why. It's like, I just want to see the contents of your folder. Okay, and you should see something like this data folder. You see the data folder? Okay. So if you click there on the plus hand side, you can see here that we have, would you like to work for this demonstration with health data like lung cancer or with demographic data like age, females, males? What would you like? Who would like health data, to map health data? Who would like, okay, one health data, one demographics? Who would like to work with demographics? Okay, so demographics. So expand the US geodatabase. So that US GDP, remember that's a geodatabase. And now we're gonna drag over that one called counties. So drag it over to your table of contents. And somebody tell me what's wrong straight ahead with this map, with this data layer. Is that right? So I'm going to bring my friend over here. So whenever you see that shape, an alarm should go on, internally say, that doesn't look like the shape of the United States. Our map grabs the coordinate system of the first layer that you add. So when I added this layer, my entire map is in decimal degrees. It's basically, we just took this ball and we just like rolled it out. Decimal degrees are degrees, right? We are thinking we are in the middle of the earth, in the middle of this ball, and then we are measuring things with degrees north and east or west, right? Well, how can we measure or analyze anything when we are not working flat? And if I calculate an area or a distance, is it going to be in degrees, in decimal degrees? So that's why we never ever work when we analyze data on lat long. And so I purposely put the data in I left it in decimal degrees because a lot of agencies will give you the data on decimal degrees because it's easy to map things on top of the air, but it's not good for us for analysis. So what we're going to do is we're going to take this data set, we're going to create a new geodatabase, and this is my recommendation for you for any project you ever do, any research project. You have your folder with your original data, and then I create a geodatabase called projected data. In my projected data folder, all my data is projected, is ready to analyze. But my original data folder, I can always go back to the original data if I change something. And so that's some practice that I want to practice with you, so you will do it with your own project. Does that make sense? Okay, so have you used the project tool before? Okay, the project tool is going to take your data that is in lat long and it's going to make a copy in the projection of your choice. So we're basically going to make a copy of this data set, but in a projected, but it's going to be projected. So in our catalog, right click on the data folder, and we're going to scroll down to new file geodatabase. So new file geodatabase. And I'm gonna click on the name to call it projected underscore data. So projected underscore data. All of the data that we're gonna be using in this workshop that is projected is gonna go to this file geodatabase, okay? So now I'm going to use the tool called project to make a copy of this data set in the projection of my choice. In order to do that, we're going to look for that tool. If you go here in this menu, in the second menu here, hover over right next to catalog, you have that search window. Click on it, and it will just display this window here on the right-hand side. You see the search window is between our catalog and our toolbox, between the yellow storage boxes and the red boxes. Everybody has the search? Do you have the search window? No, it's right here in between our catalog and our toolbox, the one with the little blue ball in the menu. Is that one there? Is that one? It's maybe thinking. I think it's not working. I think. Okay. It was just waiting. Okay, here we go. All right, so there in that search box, we're going to search, we're going to type project, 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 and then hit enter. And so it's that second tool called project data management tool. You see it has a hammer. So it's funny, like you used the toolbox before. I feel like a carpenter with my different tools, and then we have the hammer. It's kind of funny. Okay. And so if I click on it, this window appears, and you can see, you might not see this help. Is down here, you have this button called show help. And if you click on it, I love the help in ArcGIS. It really is very intuitive. It helps me understand what is it that I'm doing. And when I'm clicking on each one of these boxes, it tells me, oh, here you put the feature class that you want to project. Here you put the location. So it's just really helpful. Okay, so everybody has this, this window open. Okay, so if you click on that drop-down menu, we are going to select that counties data set. And immediately reads it and say, you are in geographic coordinate system. So GCS, that means we are working like with a sphere. The data say we're in the sphere and we are working in degrees. Then very important, we are going to, and I'll show you how we change this. So you see this location here to the C drive, that is a very bad location. Our C drives get reimaged every 2 weeks. So that's why we put the data on the D drive. And so we want to avoid that temporary location on your C drive. So click here in that folder to navigate, and we're gonna navigate to this D drive data folder, projected data. And then we're gonna give it a name. I'm gonna call it counties _ projected. And you said, of course it's projected inside. You never know, long, meaningful names. If you come and look at your data a few months later and you don't remember, which happens to the best of us, long, meaningful names never hurt. So I call it counties projected, but you can call it anything that kind of makes sense to you. Remember to use underscores and no spaces in your filing names. So I click save. And so 3 things that you need to project your data. The data that you want to project, the location where you want to save it, and very important, the projection that you want to project it into. So this is going to be a recap of the projections exercise that you've done in the past. So if you click here on that, under output coordinate system, click on that button there. And so you're always going to have to make this decision every time, right? Is your new data that is going to be projected geographic or projected? So it is in geographic. Geographic is synonym of lat long. Do you want to make it flat so we can do analysis? Yes. So if we work here, my distances are in degrees. If I work in here, my areas are in decimal degree, in square degrees. We don't work in those, we work in meters, feet, miles. So we need to project this. So you're always, if your data is in geographic, is in degrees, you're always going to project it. So we're going to choose projected coordinate systems. And here's where you need to make the decisions, right? Remember when you did your projections workshop? So you are gonna have to look at projection that fits your area. And so in this case, because we want the entire US, we're gonna go to continental and then North America. And then here you have basically 2 choices in a way. You will see that you have North America and US contiguous. So the thing about projections is that you're always trying to use a projection that covers the smallest extent that you can. So if I'm working in South Carolina, I only need to project this much. But if I'm working with the entire US, this is going to give me more distortion. So I'm always going to choose a projection system that is the smallest extent that I can. So in my case, if I'm only working with the contiguous US, I'll choose that projection. But if I'm working with Alaska and Hawaii, I use North America. It will give me more distortion, but I'm working also with those 2 states. Does that make sense?
It does. I can't seem to get it to generate the output data set name. I can get to it here, but it won't go here.
Give it a name. So give it a name here, like counties underscore projected. So you wanted the location in the name.
Okay.
There.
Okay.
Yeah. And now we go here. Yep. And then we are in projected, and then continental. Because we're working with the entire continent. So I think for this purpose, because we're not going to be focusing on, for our map and how we're going to be using the data, let's use contiguous, because I'm not going to look at Alaska or Hawaii right now for this exercise, for this mapping exercise. So what we're going to be doing is we're going to choose NAT 83 contiguous USA Alvers. Alvers is an equal area projection. It tries to keep the area of each counties proportional. So there's no distortion. So the size of this county over here is comparable to the size over there. Remember with projections, you need to decide, is my goal distances, areas, or shapes? And based on that, you choose your final projection. Yeah.
Based on this, when you go to choose this, what's the difference between just NAD 1983 and NAD 1983 with the 2011?
So the NAD 1983, that's the datum.
Mm-hmm.
The datum is a series of locations that have been very precisely mapped.
Mhm.
And so then the first one, 1927,
Okay.
that was like maybe 300,000 points and around the entire world. The one 1983 was millions of points. The one in 1983, 2011 is even more recent. It's like an updated version. So depending on like your other data, you will choose it. So those are minor, but it's still important. So for surveyors, if you're a surveyor, that really matters. If you are looking at the entire US, as long as your data is not in lat long, and you're looking at something that keeps the areas proportionate, you're in good shape.
Okay.
But for surveyors, it's like that can give you the difference of being in the road or being in a, on the sidewalk. And so that's big, but that's a very good question. I don't know if you ever seen one of those datum. Have you ever seen one of those these metal things that you see on the floor that says USGS you'll be fine? Those are the datum. That's what we use. They've been very precisely located compared to the center of the Earth. And so because the Earth is not a perfect sphere, those locations allow you to see like the real shape, measure the real shape of the Earth. And so do not take them away. They're very important to help us. Okay, so everybody's getting this 983 contiguous USA Alvers. Yeah, so we click OK, and then we click OK one more time. And now what it's going to do is just going to create the same data set, but now it's going to be projected. Do you see something like this? Do you see it? Yeah, I mean, it might be a different color.
Right.
Why are they exactly the same? I just projected in a very different projection. Why are both of them? It seems like nothing has happened. Anybody?
Just overlapping it, just overshadowing.
Right, but one is in, yeah, that's correct, but one is in lat long and the other one is in Alvers. Why are they not? Why didn't it change the shape? So, and this is important, I'm making this emphasis on it because, we deal with this all the time. It's because of my data frame. So, are you familiar with the concept of the data frame? The data frame is this, and it's this, it's my canvas. It's where I create my map and I bring all my data. And like I told you at the beginning, the data frame grabs the coordinate system of the first layer that I add. And if I add any other data set, it's gonna display it in the coordinate system that my data frame tells it. So I can have two data sets with very different coordinate systems, and they're gonna overlap perfectly. So what my data frame is doing right now is reading the counties projected and say, oh, you're in Alvers. Well, I am in lat long, so I'm gonna read you behind the scenes and reproject you on the fly into lat long. So it's great because if I'm just mapping there, everything is gonna overlap. But for analysis, it's deceiving because it seems like everything is in the exact coordinate system. In reality, they're not. One is in lat long and one is in Alvers. But for mapping purposes, I don't need to reproject anything. For analysis, I do, but for mapping, I don't. So years ago, our map will not do this for you. It will say, your data is in a different coordinate system. I cannot bring it in. To make things easier for us for mapping, it does it on the fly, but then you might be dealing with data that is in lat long. And some tools will simply not run and tell you, you are in lat long, I cannot run you. Any questions about this? Because it's kind of. Okay, so let's bring a base map, and now we're going to see the data, and then hopefully this will make more sense. Cross fingers Base maps are gonna work now. So if you go to that plus button, there's an inverted arrow there, which mine is not working right now. Is yours working? Mine is doing what yours was doing. Like it freezes. I need to wait. Like nothing is working right now. Sorry about that. Yeah, it's completely frozen. Everything else seems to be working fine. Let me see. Yep, it's just our map. Oh boy.
Mine drops enough that it only has the add data. The others.
Yeah, I'll show you. So it drops down, but it only has the add data. Can I see that?
Right,
Yeah, I have both.
You should have 3, right?
but they're great.
Weird. Also, don't save into the C drive
It's my speaker.
as your C drive. Okay. So you're okay. Right? I was thinking maybe because we don't have permissions there, you just did something funny. Oh, so which version do you have installed versus? But do you have like advanced? Let me see. Bring it out. There's something in the install. Did you install the entire ArcGIS? Yeah, I'm not sure, but
So
you,
this is all the workshops.
yeah, and did you add it on Basemap before, or data from ArcGIS Online? Are they just grayed out now, or they've always been grayed out?
I'm just going to sit now. I can close it and restart.
Yeah, well, even it doesn't let you sign in into ArcGIS Online. Yeah, all of the computers here have those 3 options. Like if you go to File, see those 2 are grayed out. I never seen that like that. Mine is frozen too. Oh boy. I'm gonna kill it. Bring it back. Sorry, bear with me. They've been doing a lot of changes into our image. I'm glad it's mine and not yours. Are you familiar with ArcGIS Online or base maps? All of you, base maps? Yeah. So sometimes in this room when we all trying to bring a base map, the computer doesn't go through. So while I'm waiting for our map, can you click on that inverse arrow that you have right next to add data, and then go to the second option that says add base map, and then select the street map data. If you want to, we're not going to use base maps only for this part, so you're okay with the rest, but if you want to play with base maps, then you can log into these computers. Okay, so I have my R map again, and I'm gonna catch up with you guys, hopefully. So I have my data. I'm gonna bring first And if you can, when you have that base map, did it work? Did you bring the base map? Can you right click on the base map layer and say zoom to extent? So I'm gonna first bring the counties, then the countries projected. Now I'm gonna bring the base map, street data. And I'm going to right click on this world street map and then zoom to layer. So that's basically, I use that all the time, like zoom to layer. I'm not zooming in or zooming out, trying to fit my screen, right click, zoom to layer. So this is, what you see here is this rollout, right? That's why everything is kind of, very like stretched horizontally, right? So that's the view. My data frame is in decimal degrees because I added the counties that was in decimal degrees. So how do we change the properties of the data frame? The data frame is your canvas. The data frame is called layers right now, is where I bring all the data. Whatever I tell the data frame to be, all the data is going to be redrawn and symbolized however I tell it to be. So let me give you an example. If I say I want to rotate, and this is just a demo. So if I want to rotate my data frame, let's say 35 degrees. All of my data, any layer is in 35 degrees. The data frame dictates how my data is displayed. It's my canvas, is where I bring all the data and I say, I'm gonna rotate you, I'm gonna display you. So I forced everything to be in a certain way. So as I mentioned before, the data frame, let me change it to 0 degrees. So I need to say 0. So the data frame grabs or assumes the coordinate system of the first layer that I add here. So if you go to the coordinate system tab, and how I got there, I go to, in my table of contents, I go to layers, and then I right click the layers, which is my table, my data frame, and I go to properties. And you can see that window is called data frame properties, right? And so if I go to the coordinate system tab, what is highlighted, what is displayed as a default is the coordinate system of my data frame. The coordinate system of my data frame is geographic coordinate system. That's what the county's data set was, right? And the units are degrees. I don't have meters or feet, I have degrees, right? So that's how you know, okay, what is the projection? What are the units for my map? Your data frame will tell you, right? And so if you scroll all the way down there, you can see that you have a folder called layers. And these are the coordinate system of the layers that you have in your map. So think about your data frame as your map. So I have 3 data sets. Every data set has a different coordinate system. The first one is the county is in lat long. The second one is the one we projected, it's in Albers. And the base map is in Mercator because it's a world data set. How come they match perfectly on top of each other when they have such different projections? Because the data frames force them to. It says, everybody that is coming in, I'm going to redraw you in lat long. And so if we change that, so let's change our data frame. And how we do that is just we select another one. So select the second one, select Albers, and click OK and watch what happens. So Albers is USA Albers is very precise and very good for the US. Doesn't care about the rest of the world, is completely distorted because basically what we did with this was, where are you? United States. We took this part and then we projected flat with very complicated equations to make it flat, but the rest of the world, the projection is only for this part, so the rest of the world is distorted, but I don't care because I need something for the US. And so the data frame now is redrawing the 3 layers to match others. So I know this is a lot about projections, but it's important, and it's just kind of trying to get this concept very clean. So if I right click now and count is projected and I click zoom to layer, that's kind of more the true shape of the US. Now we can start doing some analysis and some mapping. What I'm going to do is I'm going to get rid of the base map so we can all run faster. I just wanted the base map allows me to see what happens with projections and distortions, but it slows us down. So I'm going to right click and remove the base map. And I'm actually going to remove the counties, the original 1, 2. We only need 1 data set, right? And so I'm going to remove the counties data set. And so I'm going to stay only with counties projected. Okay, so we should have just 1 layer. Everybody, 1 layer? Okay, so I want to symbolize my data. I'm going to right click and open the attribute table. And here you have your typical data. What would you be interested? Let's say, for example, this is why I did H5. We have a flu epidemic and we really need to know, we're working for the CDC. We need to know where the children under 5 are, right? So we can send more resources for the flu. Does that sound like a good, okay? All right, so if I want to symbolize my data set by that field, by that column, how do I go about it? How do I do it? 95% of the answers in our map are always right-click properties. Right-click properties. And which tab do we go to for changing the symbology? The symbology tab. And because it's a quantitative field, number of children, we're going to go to quantities. And then the value is going to be H under 5, H underscore 5. And then let's click apply. And then you can see, of course, that we have, the counties with the highest population is going to have the highest number of children too. So what will make sense in terms of normalizing? I want to see the percentage of children compared to the total population. So a very easy thing to do is we're going to click here on normalization. And then we're just going to choose like POP 2010. So in this way, I'm going to have children, percentage of children based to total population. Which one makes more sense for that case? Number of children or percentage of children? So for some cases, percentage, right? So do I have any more children compared to the total population? But if I want to give number of vaccines, maybe I need the total number. So those are questions that you need to you need to think about. Like, what is my map representing? What is the data? And is this really what will be useful to them? So let's just leave it now because it gives me more variation. Let's normalize it. So H under 5, normalize it by total population. So you can see here, I'm going to click OK. And I'm going to call these counties. I'm just going to create kind of an alias. It's countries projected, but I'm going to, and bear with me, I'm going to call it natural breaks. Okay. And the reason why, if you, and just, you don't need to do this, just look at it. But the default for your data is natural. To classify your data is 5 classes natural breaks. If you click in classify, you see the histogram of values, right? So what does this mean when you look at the histogram here? Anybody cares for interpreting? We're looking at percentage of number of children for all the counties in the United States. And this is the histogram of values. Do we have a lot of counties with very small percentage? No. Do we have a lot of counties with a very high percentage? No, just a few. Most of them are around the mean or the median, right? So just so you can start understanding. So are you familiar with natural breaks classification method and what it does? So natural breaks is looking at this histogram and it's trying to, if you force it to say, I need 5 classes, so it will be different if I say 4 classes or 6. But with 5 classes, it's trying to put these breaks when it thinks there's a natural break in the histogram distribution. So what it's trying to do is to minimize the difference within the counties in each class. So it's thinking, if I put a break here, I think these counties belong to the same class. But it's trying to maximize difference amongst classes. So it's trying to say, look, there's a clear break between this class and this class. These counties are fundamentally different from the counties in that class. So it's trying, based on the shape of your histogram, is looking at those breaks. Says, look, there's a big jump from here to here, that's a break. Does that make sense? So it lets the data decide where those breaks happen. And that's why it's called natural breaks. Watch what happens if I change it from 5 natural breaks to 3. Here's my first break, second break. So this is 1 class, second class, and third class. Watch what happens to my map when I select 3 classes instead of 5. Very different. Same data, very different. The number of classes you choose for symbolizing your map will give a different message. Do you see that? So if I change the number of classes from 3 to 5, now I have more variation, right? It's the same data, so it's not that this one is wrong and the other one is right, in a way. I'm not lying with the values of this data, but what I'm saying is, well, I'm grouping counties that have 0 to 0.05 in one method, and the other one might go up to 0.07. Who determines that these counties are in the same group or not? You are doing that, and you're making that decision. And that's an ambiguous or arbitrary decision. Why should I use 3 classes and not 5? Or 5 and not 7? When you're changing your classification method, you're changing like the grouping and say, this is 1 class of counties, this is another class of counties. So let's just leave it with 5 classes and click OK. And now what we're going to do is I'm going to right click this counties projected. I'm going to copy it and pasted it again. Sorry. And pasted it again. So what I'm doing is I'm using the same data set twice. This is exactly the thing that we use when we want to reuse the same data in a different way in the same map. So do you have the second one? I'm going to rename it.
How do you get it to paste?
Sorry?
How do you get it to paste? I can copy it.
Yeah, Control V for something reason doesn't work. So just go to that paste button there under bookmarks. There's a paste, like like you have in the.
Oh, okay.
On like Word.
They're grayed out.
That one is paste. Yeah, did you copy it?
Oh, okay.
Yeah.
Okay.
And so the second one at the top, we're gonna call it equal interval. So countries project, and this is just an alias, but then we know in our map which one is what. So I'm gonna remove that natural breaks, and I'm gonna call it equal interval. Okay, I just click on it and click on the name again, and it allows me to edit the name, like you do with Word documents too, or Excel spreadsheets in file. And now I'm going to change the symbology. So right click, properties, and then in symbology, click on that classify. You go to the symbology tab, and you can see the classify button, and you click that. Let's change the classification method from natural breaks to equal interval. So equal interval is going to say, look, I don't care about the distribution of values. I'm going to make equal classes of the same width. And whatever falls there, if I 1,000 to 100,000, and it's something that the people can understand better than if we start using natural breakers like 37,000, 80,000, or things like that. So let's see what happens when we choose equal interval. So we click OK, and OK again, and it's a very different map. What happens is, like I mentioned before, I barely have any county in the very low class and barely any county in the very high low. But if you look at here in your table of contents, you can see the difference. The first one is saying 0.025 is a class, and the second one says 0.2, 0.5. So one is saying half of that value is the same class, and the second one is saying no, we go up to 0.05. One is saying these counties belong to the same category, and the other one is saying no, the category is going to that. So, 5% versus 2.5%. And so when you make that decision, of course your map is going to change. So let's do one more, because I need to show you this one. So I'm going to, again, right-click and copy, and then click on the paste button. And then this one is going to be, instead of equal interval, it's going to be quantiles. So quantiles is very interesting. You right-click properties, and then go to your symbology tab, click the classify button, and in your classification method, change from equal interval to quantile. Quantile forces equal numbers on each class. So equal number of counties are going to be in the lowest one, and the middle one, and the third one. So if I have, 3,000 counties, I'm going to have 1/5 in one category, 1/5. So your map is always going to be very balanced. Politicians use advocates. Everybody kind of use this to. It's like the same data, right? But now it's not a problem. Here you have as much as this one or that one or that one, and the data is the data. It's not that anybody has manipulated data, but it's just very, very balanced. I have same number of counties on each category. If I present this map and I say I have, look, some counties with very low percentage of children, but I also have a lot of counties with a high percentage of children and a lot in between. It's great. It's like, but if you see there, you can see how it made the cuts, right? And what it makes a lot of sense is like the cuts, like those breaks in the histogram, because it's trying to fit the same number of counties in each category. So which one is right? Right. Which one should you use? Well, depends on your purpose. But then the other thing is that what if we, instead of using this ambiguity or this arbitrarity, we use the spatial statistics? So I can give you high concentration of counties with a lot of children in a certain area. And instead of talking about classification methods, I talk about p-values and scores. I take that ambiguity out of the question. So that's kind of where my long point to get to, like, spatial statistics. Any questions about this exercise? I know it's a lot of basics, but I thought it will be useful before we move on. So exploring your data. So things that we need to consider, like you will do in any statistics, you need to see if your values are normally distributed, if you have any outliers, if you have variation of your values. Do I have just a bunch of zeros and ones? And what am I going to try to cover from those? But I think one of the most important thing is we're going to talk a lot about spatial autocorrelation. And that's the basics for all of our spatial statistics that we'll be looking at. And basically, spatial autocorrelation is based on the first law of geography that says things that are closer together, they tend to be similar in value. So if you and I live in the same neighborhood, chances are is that we'll be more similar than if you and I were living in two different parts of the country. And so when that happens, when things are closer together, tend to be more similar, that's where we start seeing patterns and relationships, and that's where we start looking at statistics. So all of the statistics tools that we're going to see for spatial statistics are in this spatial statistics tools in our toolbox. But before I'm gonna show you how some really cool tools that are part of the geostatistical toolbar that you probably use with Blake for interpolation. So I use those for exploration before I start spatial statistics, and I'll show you those. Okay. Let me bring it in. So let's bring our map again. And let's get rid of quantiles and equal interval. Let's just leave, I mean, you can choose whichever you want. I'm just gonna have right now natural breaks, this very same data set. Okay, so what I need you to do is to bring the geostatistical analyst. And so how you do that, you go to customize, extensions, and then you will see that right there in the middle, there's a geostatistical analyst. Check that box. And you will say, you might ask, why don't we have all of those boxes checked in? If we have all of those boxes checked in by default, our map will not take 5 minutes, it will take 20 to open. So that's why, Sarah, why do we have to do this every time? And then after you activate that extension, right click anywhere on this gray area and then check that geostatistical analyst toolbox. So for interpolation, there are entire classes just talking about interpolation. You have to really explore your data to decide on the interpolation method. So ArcGIS has this awesome geostatistical analyst tool just for interpolation. I just use it for everything else, and I hope you will explore that as well. So does everybody have the geostatistical analyst toolbar? Okay, is it green? Like, yeah, okay. So if you click on that drop-down menu there on the geostatistical analyst, you will see this explore data. And so what I want you to do is let's start just with the histogram. And my histogram disappeared. I think that might be the problem with my ARMA. They go somewhere. This one is working. Does yours show up? Yeah. Can anybody help me? Why is mine not showing up? The other ones do. Voronoi also not working. String analysis not working. So the ones that I want to show you are not working. The ones that I don't want to show you.
Is it popping up under that window?
Yeah. Yeah. What if this one is for the... I just think that's what's happening, but I don't see it in any other location. Let me see. Well, I just used this last week, like right here. The semi-variogram at least gives me that. It shows somewhere else, but the three ones that I want to use, like, can I use my laptop? No, because we have all of this. It's like the three that I used last week.
Right. Can we save the map? Close our map,
Those are map.
bring it back.
Okay. Sorry about that, but
This one, that one.
if you want to write a ticket, I guess. I just think them, re-imaging all the time and just they work same data, other computers last week, right now. Are you able to see? Can I just talk about it while you guys? I'm gonna try to bring our map back and see if it gets happier. This is not, we don't manage, this is not my personal computer, so I cannot control when it works or when it doesn't, but this is not what you will expect from any computer to respond, just so you know. You'll get discouraged with our map. I don't understand either. Sorry, I cannot show them to you. I'm just gonna talk while you look at it. But the histogram, if I look at the regular histogram here, and if I look at my, where is H under 5, so this is like the old way of doing things. You go to statistics and it gives you a histogram. And so you can see the values for each county. Well, the histogram that you're putting in is interactive. So if you select this bar here, it will select them in the map. And so you can start looking for those outlier counties that we have. And so to me, it's very interesting that it gets to be interactive and then you can work with it. And I really was looking forward to showing you that. Are you playing with it? You can change in the histogram window at the bottom, you can change the field. So change the field here in the histogram will have any field in your attribute table. So you can look at H under 5 and then see the histogram for those counties. I'm gonna go around and talk here. Yeah, so you can select any value. Yeah, and then if you select like these counties here, you can just drag over it. So create like a rectangle that just overlaps with that. You can see where they are. Yeah, exactly. So you can see like where are those, for example, so you can create a rectangle that overlaps with it, like that. Yeah. It's just easier than.
Yeah.
Yeah. So I don't think there's any here. So you can grab from here. And you can change the bars to 20 bars or, to see more variation and more classification. And then if you click on add layout, it will add it. I will add it to the layout view.
Okay.
So you have your histogram and your map. I just think that's kind of neat.
Mhm.
And you have a bit of,
Well,
yeah, more variation.
yeah, the projection we had for the baseline.
Yeah. Yeah, well, it's the one that we projected to. So I chose Albert, not the baseline. Okay, right click on layers. Yeah, and properties. Like your data frame, yes, and then so scroll down. And then choose, layers, choose Albert. Yeah. And then click OK. Yeah, and if you click add to layout, you can even see, like, it will add it with the selection and everything. You're playing with it? Okay. Can I get a cable to hook on my laptop here? But I really want to show them the trend analysis. So there's a trend analysis that, to me, I really need to show you that. You can also play with the Voronoi map. So let's say, for example, if you go back to the data folder, and then you bring, for example, like nuclear facilities, and we have point data, and we want to see like the service areas for nuclear facilities. So where in the US are we closest to one nuclear facility versus the other? And so what you can do is click on that geostatistical analyst, explore data, and then click on Voronoi map. So what the Voronoi map is going to do. I'm going to show them this one here. So if you have, and this is the US, sorry, very rough terms, and then Florida. And then you have those, let's say we have this ones here. So what the Voronoi maps is like, it connects, like, let's say 2 nuclear plants, and it creates a straight line. And then it, right through the middle of that straight line, the midterm point, creates a perpendicular. Then I'm gonna put them like this so it's easier to see the boxes. And so now I'm going to connect these 2 nuclear plants, and then through the middle, I'm going to create another one, another perpendicular through the midpoint of that straight line. And then I'm going to do the same thing here. And then I'm going to do the same thing there. And then I can do the same thing there. So this polygon here means anywhere inside that polygon, I'm closer to that nuclear plant than any other. And so it creates, when you don't have boundaries, because a lot of times, for entomology, for health, for when I go to get gas or shop, I'm gonna say, oh, I'm crossing the boundary line. Now I don't shop here. Or if I'm, a bug or a disease, I'm saying, oh, I'm not crossing over, right? So those artificial boundaries that we have with counties or city boundaries, or that they don't make sense, but this will make much more sense because you tend to go to the closest place that you are. When you are distributed, you look at those areas of distribution. So play with it a little bit. I cannot show you right now the Voronoi map, but what you can do is select those nuclear plants, or I also have a layer with mine plants in South Carolina, and then you can look at like that area of distribution. So let's say, for example, if I were to put a new hospital, I can look, that data could be all my existing hospitals, and then I can see if I need to put a new one, which one will be the area that, is the largest for an existing hospital. Does that make sense? Have you heard of Voronoi maps before? Voronoi? They're called also Thiessen polygons. Thiessen polygons? No. It's just you create this like area of influence when you have some point data. And then I'm gonna try to show you this very quickly. I need to do something like
Duplicate or extend. And is it on 2 or is it on 3? Okay, there it is.
Okay, so we can see that. Perfect. And can the Google Hangout see this screen? No, sorry about that. Okay. I just want to show you the trend analysis, so I'm gonna bring the same data that you have. Mine is not projected right now, so the raw data. But just to give you an idea, let's do very quickly the trend analysis. And so what I find fascinating about this is that you can see in 3D your data. So same as you did on the other ones, if you have your layer counties and then attribute, I'm gonna leave population in 2010, so because I think we're more familiar with those. Basically imagine what you have here are the values on the C axis, the values of population for each county. So I'm going to change the sticks so they are not so prominent to like a dark gray. And so what we have in the XY is the location of each county on that plane. And then on the C axis, we have each stick is the value, that ball at the top. That's the length of the stick is the value of population for each county. So in order to rotate this, if you click on that, on this wheel over here, I'm not doing very well. I'm not rotating that right. I'm gonna put it back so my X and Y kind of fit there. One easy way to do it is change where it says rotate. See the rotate button on the left, change from locations to graph. When I change that, look what I'm doing. I'm putting that's the shape of the US, right? That's all my data. Now I'm looking it down, right? Those blue dots on that wall, imagine I have my data here, here's all my counties, and I have a big light, like a big torch, how you say torch, like flashlight, like a big flashlight that is just projecting those values and that wall. And so that wall there is north to south. So I'm going to be looking at the trends and values from north to south. And then the green wall with values there, imagine I have my data and then I'm projecting their data, those points. So I have a flashlight from here to there and it's projected on that wall. Those are east to west. Does that make sense? So we have the blue wall will be the values projected north to south, and then the green wall will be the values projected east to west. Right, and so what we're trying to see here is that we have any trends. The trends are the lines. The blue line there is the trend north to south, and the other line is the trend east to west. And so if we look a little bit closer, I'm gonna make those I'm gonna make that trend data, sorry, the trend and projections a little bit thicker. And now I'm going to rotate back so we can see it. So if you can zoom in a little bit, what would you say is the trend east to west? And I mean, east is Alaska and Hawaii. Like it goes up and then it starts going. Right, exactly. How about north to south? So I'm going to rotate it there so I can see it better. If I look at north to south, what is that trend line telling us? Do we have more population in the north, middle latitudes, or south? North or south?
North.
More population north? North there, right? But if we look at north, like Alaska north, then we see that there's obviously more population here than over there, but less population than south, right? So this just gives you a perspective as, you know, for spatial statistics, we're also looking at like, do I have any directional trend? Do my data just change a lot? And for forestry and for entomology, that might be very well the case, and it might be an interesting perspective. The beauty of it too is that I can select. If I select some points here, it's going to, and I zoom out, it's going to select them in my map. Let me see if I can make this smaller. In my map here, in the XY plane, and then on the projection planes too, which is pretty cool. So I can look at individual counties and say, oh, here is it. And if I'm looking for this very high point that I have here, what is that county? It's going to show it to me. So it's LA, and it's going to show it in the XY, and then east to south, and the north to west. So you can select interactively each one of those, and then add it to your layout as well. So these are just ways that you can explore your data. These are the scripted statistics that you can look at, but they can, they can start giving you a sense of which other spatial statistics tools to use, and if you have any trends, outliers, and things like that. Any questions? So we're gonna take a 5-minute break, and then we're gonna come back to do like mean center, standard deviation ellipse, and more exciting things. Right now, we've just been exploring data. I'm sorry, Kali, for the difficulties.
Everybody get a chance to log in.